Our session is about 5G key capabilities. What are different capabilities of 5G? We will talk about. Primarily, we will be focusing about the vision of ITU onto this 5G key capability. So let us start. So let us first understand the role of ITU. ITU is International Telecommunication Union that you may be knowing, and you also be knowing that ITU has got three sectors. These are ITU-R, R stands for radio regulation, ITU-T, which is for making standards, and ITU-D for development. So the ITU-R is mainly for managing radio frequency spectrum and satellite orbits. It also ensures that radio communications are operated interference-free. ITU-T is for standard, so ITU-T produces standard and also defines tariff principles for international telecommunication services.
Sir, I'm audible, sir. Hello?
Yes, yes.
Sir, please, sorry, sir. Okay. Okay, sir.
Okay.
I'll mute.
ITU-D for development, so which facilitates creation, development, and improvement in the area of telecommunication and ICT. So our focus today is on ITU-R. ITU-R because on 5G, this is ITU-R which creates different requirements, etc. So what ITU-R does in respect of mobile communications? So ITU-R creates, as you can read, vision of upcoming mobile technology. What should be vision or the framework of a upcoming mobile technology that is defined by ITU-R, radio communication sector of ITU. So ITU-R also defines minimum technical performance parameter of a radio technology. And finally, they also define the evaluation criteria. So once the vision and minimum requirements are defined by ITU for a upcoming mobile technology, the SDUs across the globe are free to develop a candidate technology or the detailed standards, and they submit it to ITU for approval. So ITU has an evaluation criteria for evaluating such candidate technology. So let us look at various technologies for which ITU had created a vision document and requirement, and what was the outcome. So they started with 3G. Up to 2G, I mean ITU was not creating requirement document of the mobile technology. 3G onwards they started. So when they created vision and requirement for 3G, they named it as IMT 2000 technology. IMT is International Mobile Telecommunications. So the name of 3G given by ITU was IMT 2000. May I request that you keep your mic?
Sir, do you have any presentation or presentation is not there, sir?
Presentation is going on. I think you reconnect if you are not able to see.
I'm not able to. Should I reconnect again?
Please reconnect.
Okay.
Let me confirm from others whether it is visible. Can others confirm
Yes,
that?
sir. It is visible.
Yeah, visible.
Yes,
It's
it's visible.
It's visible.
Yes, sir, visible, sir. Visible.
Visible. Okay. So anyone not able to see, he has to reconnect. See your broadband connection. If broadband connection is poor, you may not be able to see.
Sir, one request, sir. Sir, one request. Hello.
Yeah, write in chat box so that class continues.
Sir, one request, sir. One request.
Okay.
Am I audible, sir? My voice.
Yes.
Okay, sir. Thank you. Thank you, sir. Thank you.
Okay, so may I request all of you to keep your mic in a mute mode? Thank you. So the two technology got approved by ITU as 3G technology, one from the 3GPP family, third generation partnership project. So in the morning, we heard about WCDMA, that was a GSM evolution. So that was approved as one of the 3G technology by ITU. In addition, ITU also approved CDMA 2000 EVDO, revision A and revision B as 3G technology. But all of us know that this particular technology, WCDMA, UMTS, became kind of one of the popular or successful 3G technology. During 4G era, so the name given by ITU for 4G was IMT Advanced Technologies. IMT is again International Mobile Telecommunication Advanced Technologies. Commercial name is 4G. So there also two technology was approved by ITU. One was LT Advanced, that is release 10 of 3GPP, and IEEE family WiMAX. WiMAX you may be knowing. This is 802.16M. This version of the WiMAX was also approved as one of the 4G technology. But what succeeded is the LTE, not the WiMAX. Although many operators, including BSNL in India, tried WiMAX, but it didn't become successful. In front of 5G, here also initially two technologies were approved. One was 3GPP new radio, which we talked about in the morning. And India had also submitted its own 5G technology called 5GI. So that was also approved by ITU as one of the candidate technology. But later on, it got merged with 3GPP release 17. So now we have a single uh, NR technology, 3GPP NR, which is the 5G technology as of today, single unified technology. So let us talk about, I'm giving you the name of the document of ITU. I talked about they create vision and all. So if you look at this, M.2083, this is a document which is also available publicly. If you can Google or download this. So this is a document which gives you IMT vision, overall framework and objective for IMT 2020. So IMT 2020 is the name given for 5G. So this is the 5G vision document of ITU. This is the 5G vision document of ITU. I request all of you to download and read this document. I'll also try to upload on the Teams. So this gives the complete vision and objective of 5G technology. And as you can see, this was released way back in 2015. September 2015, it was released. Later on in 2017, they released another document called M.2410. And this is the minimum requirement I was talking about. So this gives the minimum technical performance requirement of 5G radio or the NR. So 2017, this was released. So we'll be focusing on this document today. So I would also request all of you to download this and please read this document. And the third is the evaluation criteria, right? Third is the evaluation criteria. Once 3GPP or any IEEE or any standard making body develops a candidate technology meeting this requirement, they submit to ITU following this template or the evaluation criteria, and ITU, our sector of ITU, they evaluate, they have a committee, and then either they pass or fail, and that becomes a candidate technology of ITU. So this is the life cycle which they follow. So please download these three documents and do read it. Okay, so let us look at various standard developing organizations. So as I said that 3GPP is one of the organization which develops mobile technologies. IEEE is the other, ITC is the one. There are many, so I have listed some of them. From India, it is TSDSI. And what is the work of such standard developing organizations? They develop candidate technology meeting the ITU requirement. ITU requirement means this kind of a document. So every technology, they will release some document, and SDOs has to develop a technology following or meeting that particular requirement. Once they have done it, they submit it to ITU. ITU evaluates and either approve or not approve. And these standard making bodies continues evolving the technology even beyond what was the requirement given by ITU. For example, if you look at 3G, they went beyond whatever was the requirement. 4G also they have gone beyond. 5G also the same thing is happening. So this is the work of SDOs. This is very important timeline document of 3GPP. So although any SDO is free to develop a technology as per requirement of ITU, but 3G onwards, what we have seen that whatever standards were developed by 3GPP, third generation partnership project, that become de facto technology which entire world is following. So let us look at timeline. So just you may recall that 3G started with a version called R99. So earlier the name of the standard used to be the name of the year itself, right? If the standard is coming in year 98, they call it R98 or R99. Later on, they shifted to version 3, 4, 5, and so on. So 3G, the first release was R99. Then release 4, 5, 6, 7. Even it went beyond up to this releases. You can see this blue color. But after release 7 in about 2008-9, we had release 8, which is now 4G LTE release, right? So, but the real 4G came in release 10, meeting the ITU requirement. So that's why we call it real 4G or LTE advanced. And later on, LTE evolved, and then they gone to say 4.5G, and they call it LTE Advanced Pro, where a lot of other techniques were added. So it went up to release 14. At the time of release 15 in year 2019, first 5G release came, that is release 15. So 5G came here during the 2019 release 15. But 4G also continued to evolve. When today they are evolving 4G along with 5G, a lot of new technologies are getting added. And now what we expect that like release, so today what has happened, release 15 is out, release 16 is also out, release 17 is also out in 2022 June. Now release 8 work is going on, so this is now being considered 5.5G or 5G advanced. So by this release, all the ITU requirement will be met by release 17, 18. Beyond this, it is kind of precursor to 6G. This is some sort of precursors to 6G. So although 5G will evolve through subsequent releases, but we expect that by 2029, the first 6G releases may come.
मैम बोल रहे जब मैं सुबह आऊंगा तो यार कैसे रुकूंगा देखता हूँ, पक्का नहीं है कि रुक पाऊंगा.
I request everyone to keep your mic mute. So in 2029, we may see 6G first release, but 5G will continue to evolve as. So to conclude, what we can say that any technology gets matured after 2-3 releases. For example, LTE after 3 releases, 8, 9, and 10. R10 becomes the mature technology. Similarly, 3G got matured in release 5, and 5G, although first release was 15, 16. So by 17, it will completely mature and meet all the requirements. So it takes few iteration of releases to actually meet all the requirement which ITU gives in their vision and requirement of it. Okay, so let us look at various 3GPP releases of 5G and what feature they may have. And start with release 15. So release 15 was focused on enhanced mobile broadband, EMBB focused. And what was the different features? So, and it was released in June 19. So we say that all the foundational design or requirement was taken care in the release 15 itself. So that's why we call it new radio foundation. And it was supporting service-based architecture, non-standalone and standalone mode of working. It was supporting network slicing, massive Internet of Things, ultra reliable low latency communication, and network functions were talking to each other on API, and it has got API exposure function and V2X. These were various features of release 15 of the 5G that came into 2019. Please remember that commercial equipment becomes available after almost 2 years of the release, 2 years. So it takes about 1.5, 2 years after the release happens from 3GPP to get a commercial equipment. So now, based on release 15, now whatever equipments are there, uh, they are being supplied based on release 15 and all. So 2021 onwards, equipments were available. 3GPP release 16, which came, was industry focus. It was focus. Its focus was on industry, use case in the industry, and it came in 2020. So this was the pandemic period. All the meetings of 3GPP happened online, and even with that, they were able to do the release. So it was mainly focused on enhanced URLLC, ultra reliable low latency communication, particularly required for industry use cases. Then they had something related to industrial IoT. Here, support of NB-IoT, narrowband IoT, which was there from 4G era. So how this NB-IoT can coexist with 5G, that standard is there. Then they also considered utilization of unlicensed band. Unlicensed band, for example, for Wi-Fi, 2.4 gigahertz spectrum or 5 gigahertz spectrum is an unlicensed spectrum. So that type of spectrum can also be used for 5G. So that feature came in release 16. Release 16 was also having side link, which we discussed. And then it has got IAB, integrated access and backhaul. So I'll talk about this in the second session today, finishing this. And then there was some improvement related to positioning and other bug fixes and enhancements. So release 16 was primarily industry focus. Release 17 of 5G came very recently. So it is NTN focus. What is NTN? Can anybody guess and write in the chat box? What is NTN? Anyone who want to reply in the chat box? My question to all of you that what is NTN? Yes, Rahul Jha had answered correctly. NTN is non-terrestrial network. So the satellite is one of the example. A drone can be another example, or the network we use for aeroplane and all is kind of NTN. We categorize that. So basically, in this came in 2022, June 2022. So major focus was to integrate satellite into 5G, and it also supported mobile version of integrated access backhaul. It also came out with a feature like NR Lite, we call it, new radio light or red cap. Red cap means reduced capability. It is some sort of similar. In 4G, we went as NB-IoT. In 5G, we are going as a NR Lite. Then multicast broadcast feature, and here you will also see PTTs. There was some question in the morning. The PTT support, the slicing into the radio network, some features related to that, and certain enhancement. And there is one feature called ATSSS. We'll talk about it in the 5G core lecture. So this allows non-3GPP access, like you can use your Wi-Fi at home to make a call or make a data call. That kind of feature we'll talk about later in the classes. Now let's look at release 18. So release 18 is some sort of work in progress. This has not been released yet. 3GPP is working, and they may take almost 6 to 8 months more to actually come to a release of 5G, release 18. So basically, prime focus here is that how artificial intelligence and machine learning can be used in the radio, how drone and satellite becomes part of the 5G. They will work on more accurate positioning, green network, energy, less energy consumption and all, and smart repeater kind of concept, full duplex in TUD, and many more. There are so many features. And so these are different features and different releases of 3GPP. Okay, let's proceed. Okay, there are some questions. So let me pause here and take some of your questions in the chat box. Those having any question can write in the chat box. I'll try to answer. So there is one question is that how is RAN slicing different from network slicing? That is the question by Venkat Praveen, Mr. Venkat Praveen. So basically, any network, including 5G, will have different component, different part of it. Starting from the air interface, where you have radio, then you have backhaul, the transmission media, then you have core network, and then you have a data network or service server hosting the service. So the network slicing is nothing but creating a virtual network. So one is that within say 5G core, I have virtualized into different part for different services. So network slice within the core becomes possible. On transmission network, uh, you create different partition or the tunnel for different services. Similarly, on the radio side, you have to devise certain method by which the radio resources can be partitioned as a slice. So what we are talking about in release 17, they came out with standard how the radio resources can be actually sliced in a better way. So that concept came in release 17. So when we say network slice, we say end-to-end slicing, including everything. But in the initial releases, the standard had not talked about how it will be done in the radio part. It was left up to OEMs and all. But in release 17, they have made it part of the standard itself. I hope I answered your question. There is another question that the radius are what is IAB? So IAB is nothing but, as the name suggests, integrated access and backhaul. That means one BTS acts as a backhaul for the next BTS. So you don't need a transmission system. There are certain use cases I'll talk about when I go through the 5G radio lectures. I'll give more detail on that, but you just understand for time being that normally for backhaul you require either fiber or a radio, but in case of IAB, the previous base station also works as backhaul for the next base station in addition to giving services to the actual user. So I think there's no more question. So let me proceed. Okay, so before we go into more detail, let us talk about 5G adoption and its proliferation. So basically, as we have seen that many technologies are conceived or invented in the area of communication, but some of the technologies succeed and some of the technology do not succeed. So let us look at what is the status of 5G, whether it is succeeding or it is failing. So this particular graph I have taken from Ericsson Mobility Report, which they publish every 6 months. It was taken in the November last year. So what it says that if you look at this graph, this orange one is for 5G and the green one is for 4G. And they have taken a period of 2009 to 2018, and 5G they have taken 2018 to 2027. So what they're trying to say that the time it took for 4G to reach 1 billion mark, that is 100 crore customers, and time 5G has taken to reach this 100 crore mark. In fact, 100 crore was reached in December last year. So it is 2 year. I mean, time taken is 2 year less in case of a 5G. That means the 5G adoption is faster by 2 years compared to 4G in reaching 1 billion mark, a billion mark. So 5G has already surpassed 100 crore. I think it is 1.23 crore in December 2022. So it has already crossed 123 crore. Sorry, 1.23 billion, we should say. So we have 123 crore customers on 5G as on December 2022. So uptake of 5G is much faster compared to 4G. And also, even if you look at in our country, the devices which we are getting are all 5G devices, although it is supposed 4G. But ecosystem of devices has already almost matured, and we get 5G devices at the same rate we are getting the 4G devices. This is another graph which forecasts number of customers of different technology over a period of time. So it is starting from 2017 to 2028. So in 2022, there were about 8.4 billion mobile customers. Is 840 crore mobile customers. And if you see the contribution, the green one is 4G. So 4G was highest 2022, and 5G was this much, very less number, or as we said, it was about 1.23 crore. And rest were 3G and 2G. Just you can see blue and orange. But over a period of time, what you see is 5G is growing. So now by 2028, this becomes 5 billion, 500 crore 5G connection. But the point to note here that even 4G will be almost equal in number, slightly less, maybe 4 billion about. So by 2028, you will have 9.2 billion customers, out of which 5 billion will be 5G and rest will be 4G, and very small number on 2G and 3G. Even then, we'll have 2G and 4G technology working. So this is also coming from Ericsson Mobility Report. So what I'm trying to say that 4G will continue to be available along with 5G for a very, very long time, up to maybe 10 years and all, 8 to 10 years. 4G will continue to evolve along with the 5G, but 5G number will keep growing and 4G will keep declining beyond that. Now there are some questions in the chat box. Let me try to address that before I proceed to next. Let me erase the ink first. Okay. The question is from Vinod Kumar Sharma. Which 4G version has been developed by C.DOT late consortium that has been deployed by BSNL currently? So C.DOT has developed release 14 compliant release 14 compliant 4G network, wherein they have taken care of the CUPS architecture, that is separation of control plane and user plane, and that is the equipment which the consortium will be supplying. Whether it was tested in Chandigarh as a pilot, and some of the base stations which are being installed uh, are being connected to that. But more major equipment would get supplied in this particular year by the consortium. And CDOT has further evolved the same core to 5G NSA version of that, and the field trials they would be starting in BSNL, and maybe they will upgrade the BSNL network to 5G in a year time on 5G NSA initially, and then later on 5G SA. So, Vinod, I hope I answered your question. So I don't see more questions. There is one more question. There is a question by Gopalan sir that the deployment which is happening, whether it is standalone or non-standalone. So I have answer to that, sir. I have one slide. I think the next slide would be that, which will tell you that the deployment of, say, NNSA. So generally, as all the operators across the globe, as you know, will be having 4G network, and it is very easy to upgrade the 4G core itself to support 5G radio in a NSA mode, non-standalone mode. So initial deployment across the globe by most of the operators are in NSA mode, and now many operators are migrating to the SA mode because the SA based equipment started coming.
5 बजे मीटिंग है मैडम।
Okay, so I will some snapshot related to. May I request you please to keep your mic in mute mode, please. Thank you. Okay, so this will answer your question, Gopalan sir. So if you look at worldwide, there are 816. This is not operators. It's 816 operators who have deployed 4G network as on today. This figure is coming from there is a website called gsacom.com. This is an association of all the OEMs of mobile equipment. So every month there is a report you can also see. I have given a link here for this particular report. So 816 operators are running 4G commercial network as on today. And out of 816, 249 operators, just see almost 30% and all, they have deployed 5G commercial network along with the 4G network, of course. So 4G network is going to coexist for a very long time. And out of these 249 operators, only 40 operators, just see, 40 operators have gone in a standalone mode and rest are NSA mode. So in India, Jio is operating in SA mode and Airtel is operating in NSA mode. So this is the only 40 operator as of today who has gone in the SA mode. I hope I answered Gopalan sir questions here. There is one question by Mr. Abhijit. Will GSM be absolute by 2030 completely? It's a very good question. Maybe I should ask you a question. In India, we still have about 20 to 30 lakh of customers on 2G, whereas we have 4G coverage in many areas, but 2G is not being switched off. So can somebody tell me why in India we are not able to completely migrate to 4G and we are still continuing 2G? Is there any reason? Do you have any answer? Maybe you can write in chat box. Somebody says finance, somebody says remote area, somebody says range of 2G, and so on, remote location, rural DA. So lot many such answer. In fact, major problem is that about 20 to 30 lakh of the users, the rural users, they are having GSM phone. Their mobile phone is plain GSM phone. So if I just switch off the 2G BTS because 4G coverage is already there, this all mobile will stop working next day. So that's not good for the country. Connectivity of such a high number of users will be disconnected. So unless they are able to migrate to a smartphone, they may not be. You cannot just switch off. So that is one reason. There is one more important reason. So this is the main reason for India. But in UK also 2G is continuing. UK also 2G is continuing in some way. What could be the reason in 2K? Can somebody guess? Can somebody guess why even UK is not able to switch off 2G network? Somebody says they were the inventor. Anything else? Okay, let me answer. In UK, a lot of IoT use cases are running on 2G. In India also there are, but in UK, a lot of IoT devices are connected on 2G. And unless those are upgraded, a lot of people and all, I request to kindly switch off your mic. Yeah, thank you. So unless those equipments, IoT devices are upgraded to be operated on 4G or NB-IoT, you cannot just switch off. So there are some or other region in every country or operator, uh, like for BSNL, they don't have 4G, so they cannot switch off in India. So there are some region related to operator, there are some region related to the use which is there. So that's why the 2G will continue for a long time, and you cannot give a kind of a last date. But some country have done it. Like some country had announced that there'll be a sunset of 2G on a XYZ date, and everything has to be upgraded. So once you give a deadline, a government decides a sunset date, every other ecosystem works towards that. But in our country, we have not done that. It is left up to the operator and the market to decide. So we have not announced any date. For like in Singapore, they had announced 2G sunset, and today they don't have 2G network. Rather, most of their network is now 5G as of now. So they could do it being a small country, but in our country, being very, very large population scattered, we are not able to switch off 2G network as of now. Okay, let's move further. I think Gulati ji had some question about number of customers. That's a question which can be answered by operators, that how many exact number of 2G connections are there in our country. So let us not worry about that. But there are huge number which is preventing us to switch off the 2G network. Now let us come to our important topic uh, of 5G usage scenario and key capability. So basically, if you recall, I talked about a document called M2410 of ITU, which gives a requirement of a particular upcoming technology. So, and the vision document which I talked about. So this is summary of the vision document in the upcoming slides, which gives the usage scenario of 5G and also what are the key capability to support these usage scenarios. So let's go on to that. Okay, there are some questions related to Chaudhary sir. I'll be addressing later on. Okay, so let us look at ITU defined 5G usage scenarios as per the vision. So Those are enhanced mobile broadband, EMBB. Morning also we talked about. URLLC, ultra reliable low latency communication. And the third is massive machine type communication. So up to 4G, we were only talking about mobile broadband. Now we are talking about ultra reliable low latency communication and also massive machine type communications for IoT or sensor or actuators network. So to support these three usage scenario, what should be the capability of the 5G radio? How it will support that? So let us look at each one of them. So let us start with enhanced mobile broadband. So what should be the key performance requirement of 5G radios to support enhanced mobile broadband? So the first requirement we can think of is the peak data rate. How much peak data rate can be supported by 5G? So 5G supports a peak data rate of 20 gigabit per second. It's a theoretical speed. In downlink direction and uplink direction, it will be a bit half because of the limitation of your handset. So what does this mean? So if you have such a peak data rate capability, you'll be able to download a movie of say 1 GB or 2 GB in 2 milliseconds if that speed is available. And then if you compare this with 4G, it is 20 times faster. Morning we heard that 4G supports up to 1 Gbps, gigabit LTE we talked about, no, 1 Gbps of peak speed, peak data rate. If the equipment belongs to release 10, where we had 5 carrier aggregation of 20 megahertz. So it is 20 times faster compared to 4G. What should be the second parameter, important parameter for enhanced mobile broadband? It will be the spectral efficiency, peak spectral efficiency. So what is spectral efficiency? Can somebody define in the chat box? When we say spectral efficiency, what do we mean by that? Any answer in the chat box? Please write in the chat box. Somebody rate bit per symbol, number of users. Any more answers? Okay, Mr. Satyanarayana VVV. Mr. Satyanarayana VVV answered correctly. Yes.
The same spectrum can be used for downlink as well as uplink.
So it is 30 bit per second per hertz. In case of a 5G, per hertz, if you have a 1 hertz of the spectrum, you can achieve 30 bit per second, right? In downlink direction and uplink direction, it will be 15 bit per second per hertz. So let us take a math. Let's suppose you allocated 100 megahertz of spectrum to an operator. So when you install a BTS base station, so when you install a 100 megahertz, if you give a 100 megahertz channel bandwidth and he uses that on a tower, how much peak data rate he'll be able to achieve considering this 30 bit per second per hertz? So please answer in the chat box. If I have 100 megahertz of the spectrum and my peak spectral efficiency is 30 bit per second per hertz, how much data rate I'll be able to achieve? Very nice. Atul Kumar Jain have answered correctly. So many of you have answered correctly. Okay, great. So basically it's nothing but 30 into 30 bit per second into 100 megahertz. So it will be 3 gigabit per second. So but as we discussed in the previous slide, that the peak speed of 5G will go up to 20 Gbps, should go up to 20 Gbps. So how much bandwidth I require if I have to achieve 20 Gbps and I have a spectral efficiency of this, how much bandwidth is required to achieve this 20 Gbps? Can somebody do a math? Yes. Mr. Dayanand Nigam, Mr. Niranjan Prakash, Mr. Patel, Rameshwar Prasad have answered correctly. So basically it is, if you just do a math, it will be 666.66 megahertz. Theoretically, you need about 600, 700 megahertz of bandwidth. Either in one band or in mix of the band, you'll be able to achieve. Okay, so if you compare this with 4G, 4G spectral efficiency was 10 bit per second, 10 bit per second per hertz. So it is 3 times better compared to 4G. Spectral efficiency is 3 times better compared to 4G. Okay, now the next parameter for enhanced mobile broadband is the user experience data rate. So let me ask, if you have to kind of define user experience data rate, how do you define the user experience data rate? Please write in chat box if you understand what is user experience data rate. So please write in the chat box what it is. Somebody says download speed. Somebody says receive bitrate at the edge of the coverage. So Chaudhary sir has answered very right. Upload, download. Okay, so let me explain what is user experience data rate. Suppose you have base station here and it is covering a particular area. So if you go to the edge, near to the edge of the coverage, and whatever data rate you get, it's called the user experience data rate. So that is some sort of minimum guaranteed data rate one can achieve, right? So that is called user experience data rate. In case of 5G, in case of a 5G, the user experience data rate is 100 megabit per second. That means even onto the edge, you will have a data rate of 100 Mbps. In case of a 4G, it was 10 megabit per second. So it is, we say that it is 10 times better, faster compared to 4G. It is 10 times faster compared to 4G. So we talked about Acha. Okay, there is one more thing about the mobility. Mobility means when you are traveling in a bus, you are traveling in a train, your mobile still works, but will your mobile will work when you say travel at the speed of 500 kilometers per hour? So the train like maglev train in Japan and China, which goes to certain high speed, whether that will work? So answer is no. Every mobile technology is designed to operate up to certain speed. So 5G has been designed to even work at the speed of 500 kilometers per hour. So even if you have a bullet train, which is coming in our country also, and if your speed is up to 500 kilometers per hour, your mobile will still work. So in 4G, it was supporting up to 350 kilometers per hour. In 4G, it was supporting up to 350 kilometers per hour. Okay, so let me take a test from all of you, and you keep answering in the chat box. So just answer what is the peak speed or data rate in 5G theoretically. Just write in the chat box what is the peak speed supported. Please write in the chat box what is the peak speed supported. Everyone, please. Great. Then the next question is what is, okay, good, good, good. Very nice, very nice. Okay, so you have to remember uplink and downlink both. So downlink is 20 Gbps and uplink is 10 Gbps. So you guys are answering right. The second is the spectral efficiency. I need to write peak because this is the peak one in ideal condition. So what is spectral efficiency? Please write. Now the next question is what is the peak spectral efficiency? 30 bit per second per hertz, somebody wrote. Yes, somebody is writing only 30 bit or 30. That is not a correct answer. Please write the units also. Very nice, very nice, very nice. Not only the number, but also you have to write. Okay, so what is the user experience data rate? What is the user experience data rate? Only in downlink direction you answer. Just answer this question in the chat box. Very right. Pooja Varun has answered correctly. So Sanjay, good, 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 very right. And now the next is about the mobility. How much on up to how much speed 5G will work? Yes, yes, yes. Your answers are right. Great, great. Everyone has writing correctly. Very nice. Okay, so just to summarize, we have peak data rate of 20 Gbps in downlink, 10 Gbps in uplink. Peak spectral efficiency is 30 bit per second per hertz in downlink, 15 bit per second per hertz in uplink. User experience data rate 100 Mbps in downlink, 50 Mbps in uplink. Mobility up to 500 km per hour. So these are parameters to support enhanced mobile broadband kind of a scenario. Now we discussed three scenarios. So let's before I go into the next scenario, let us look at some of the use cases. So some of the use cases of enhanced mobile broadband can be 3D or ultra high definition video telepresence kind of a service, ultra high definition video streaming, like environment of stadium where a lot of people are actually watching the matches, taking videos, taking photographs, sharing on social media. So huge requirement of data. So and the virtual reality, either augmented reality, virtual reality, or XR mixed reality. So all those kind of use cases would require enhanced mobile broadband or the key performance parameter which we talked about. Now let's move to the next parameter is the URLLC, ultra reliable low latency communication. So now you people are now understanding what I'm talking about. So for URLLC, in your opinion, what should be the key performance parameters? Just name of the parameter if you can write in the chat box. Please write in the chat box. Yes, that what should be parameter for URLLC, just like we talked about EMBB. Somebody say SNR, somebody is saying latency, and so on. Reliability, rate, delay. Somebody says delay. Somebody said user plane latency, reliability, great. Okay, so the first parameter is latency. So what is latency? Can somebody define latency in the chat box? Can somebody tell me that how do we define latency? What is latency exactly? Yes, somebody said time between input and output, delay in reaching packet. Yeah, so you guys are right. So when I suppose transmit some data to you, so how much time it takes from my point to your point is the latency. So or kind of a response. Okay, so let us compare. So suppose I throw something upon you, some object upon you towards your eyes. Your eyes, in fact, blinks. So can you guess how much time our eye take to blink if some object is coming towards the eye? Can somebody guess and write in the chat box? Yes, Sumit has written correctly. Okay, so our eyes takes about on an average about 250 millisecond to react. So suppose you are driving a car and somebody suddenly comes in front of you. So your eyes takes almost 250 millisecond to react and then you take action of braking and all, right? In case of a 5G, the latency can go as low as 1 millisecond. So just compare latency of human eye and latency of whatever in 5G. Right? So just imagine, and we had compared with eye, human eye, and this latency. So just compare that. Suppose a car is being driven by a human, and a car is being driven by a machine on 5G. So human latency is about 250 milliseconds. Machine latency is say about 1 millisecond. So chances of collision would be with a human driver or with a machine driver. Can you answer in the chat box? Considering so much good latency which machine may be having compared to our human eyes. So who will be driving better, a machine or a human? Somebody is answering machine. Yes. So that's just a hypothetical question I tried. So all because the machines would have better latency and also the data would get processed at the back end. We can use AI ML kind of a concept. So going forward, autonomous car or self-driving car kind of application will become reality because of this latency. Please note here that this 1 millisecond latency is not universal in 5G. It is a specific latency which you have to build whenever you have applications related to URLLC. Not every network or every base station coverage would give you 1 millisecond latency. This will be designed when I have an application for example, if suppose uh, AIMS Delhi doctors would want to do a remote surgery in the Raipur AIMS, right? Suppose there is a Raipur also AIMS, but expert doctor is in AIMS Delhi. So AIMS Delhi will require a coverage of 5G, which gives latency of 1 millisecond, and the AIMS Raipur would require a coverage which requires 1 millisecond latency. And also the backhaul you need in a way that overall latency is maintained or managed so that remote surgery is possible. So you don't need to build a 5G network having 1 millisecond latency for everyone. It is for a use specific, because for managing 1 millisecond latency, there will be a lot of technology involved within the overall network design. Okay. So the next parameter will be reliability. Somebody had answered reliability. So what is reliability? Can somebody write in the chat box that what is reliability then? How do we define reliability? Somebody says efficiency. Neeraj Singh had said efficiency. Any more answer? Error free. Sumit is very near or right. Uptime of link. That is also correct. Error free bits. Error free bits. Accuracy, yes. Connectivity, 100%. Very right. So good answers coming. good answers coming. So in telecom world, somebody says error, a bit error free. So reliability is defined in terms of bit error rate. So for 5G, if you look at 3GPP standard, so they go up to 10 to the power minus 6 kind of a reliability. When we say 10 to the power minus 6, what I'm trying to say here that if I transmit 1 million, 10 lakh, 6 zeros on after 1, 1, 2, 3, 4, 5, 6. If I transmit 10 lakh bits, 1 bit of error is allowed. Only 1 bit of error is allowed. So that is a kind of reliability 5G can offer. Okay. So you might have heard about 4 nines kind of a reliability, 5 nines kind of a reliability, 6 nines kind of a reliability. So though that can be derived from this. So so basically that means if I transmit 10 lakh bits, so 9,99,999 bits are coming correct. This much bits are coming correct. So can you calculate this in terms of percentage? That how many correct bits, how many percentage of correct bits are being received? Can somebody convert that into percentage and write in chat box? Convert this into percentage that out of 10 lakh, I have received this much correct. So if I transmit 100 bit, how many bits will be correct? Yes, Vikas Sinha ji has written, many of you have written. So those who have written 99.4 more nines as percentage, they are right. They are right. And this is that is how we call it 6-9 kind of a reliability. So 5G will give you up to release 16. I have seen that it is giving up to 10 to the power minus 6. As far as standards are concerned, real equipment we have not seen yet, but standard says 10 to the minus 6. That means 6-9 kind of reliability it will be supporting. Okay. So 99.999 percentage of reliability and also availability. Somebody had answered about connectivity. So it's reliability and also availability should be 99.999 percentage of uptime. The next parameter for URLLC is mobility interruption. In mobile scenario, what we see that when a user is moving from one base station to other base station area, the call is handed over. Call is, we call it handoff from one base station to the next base station. So up to 4G, there is some pause in between when call handover is happening. There is some delay or pause, or we can say mobility interruption. So in 5G, that interruption has been made 0 millisecond. That means the data path will be made make before break kind of a concept. Make before break. So there will be a 0 millisecond of interruption when we use 5G. 5G standard gives that requirement. Okay. So we talked about latency 1 millisecond, reliability, and mobility interruption. Let us look at some of the use cases which these capability may support. So they can be autonomous vehicle or self-driving vehicle, robotics in the industry, aviation, that is drone, etc., and industrial automation, industry 4.0 or maybe 5.0 in future. So these where you require URLLC kind of applications. And as we saw initially that in release 16 had industry focus, industrial IoT, and they have talked about URLLC. There is a 3PP study paper on URLLC that how ultra reliable can be built by the operator, various ways they had suggested. Maybe that document I'll also be sharing with all of you. You can go through if you have. Okay, the third is about 5G massive machine type communications. That is for IoT, sensors, actuators. So can you guess what could be various performance parameter to support massive machine type communications or to support massive IoT? Write in the chat box your guesses that what can be various parameter to support uh, massive machine type communications. Chat box. Somebody says low power. Somebody says latency, connection density, user density, security. Somebody is writing. Power, energy efficiency, bandwidth, user density. Okay, so many of the answers are really good and correct. Let me go through it. Okay, so the first parameter, performance parameter to support MMTC is the connection density. So connection density is that in 1 square kilometer, 1 square kilometer, how many devices can be connected to the network? So it is 10 lakh devices support per square kilometer. So there'll be a huge network of sensor and they can actually all connect to the 5G network. So that is kind of ITU vision that the 5G network should support MMTC, and for that it has to support 1 million devices per square kilometer. The next parameter is energy efficiency. So energy efficiency not only for devices but also for the network. So has to be very efficient and energy efficient. So it is 100 times, if you compare with 4G, it is 100 times more energy. A lot of technology have gone into it. So 100 times more energy efficient compared to 4G. The third parameter is the connection density. Sorry, we talked about connection density and this. There are one more parameter which I have not talked about is the deep coverage. Not there in the slide, deep coverage. So these sensors, as you know, that will be installed in a very remote area, right? Remote area on the hills, forest, or even in the basement. So mobile signals should reach all these places. So deep coverage is the requirement. So for massive machine type communication, I should use a spectrum of technology which can penetrate deep inside. So my question to all of you is that what kind of spectrum I should use to have a more coverage or deep coverage? Please answer in the chat box that what kind of spectrum or the band, frequency band I should use. Okay, so somebody says low frequency, somebody wrote 700 megahertz, low spectrum, low spectrum, low spectrum. Yes, your answer is right. Lower the frequency, higher the coverage. So 5G will be using lower side of the spectrum to support MMTC. Very right. My next question to all of you is, we talked about energy efficiency. Why energy efficiency is important? Why energy efficiency is very important for MMTC? Please write your answer or speak about that. Yes, somebody said battery life, somebody said conservation of energy, low energy. Very right answer. That you are very right. That since those sensors, those devices will be installed in a remote area, in the hills, in the forest. For example, for sensing any disaster, you have sensors installed in the hilly area. So there will not be electricity. These will be powered by battery, and you may not be able to replace the battery. You may not be able to charge the battery. So battery life has to be 10 years, 15 years, and this is only possible when overall there is an energy efficiency, not only in the device but also onto the network, because network also because your device keeps talking to the network and energy consumption is there. So both way optimization is required so that energy consumption is very less and it can operate for 10 years, 15 years and so on. So very right. Okay, so what are the use cases? These are obvious use cases in a smart city, use cases, smart home, wearable devices or fitness devices in the agricultural field with sensors or actuators. So these are some of the use cases of MMTC. Okay, so now let us talk about India 5G IE technology, which I said that one of the India. There is some raised hand. If you have any question, please ask your question, please. Mr. Alok Tyagi from ALTTC. Alokji, if you are here, you can ask your question or I can proceed.
Hello, am I audible, sir?
Haji, yes.
Sir, you have just discussed about the reliability. The reliability is supposed to be 10 to the power 7, I guess.
So if you look at 3GPP specification, there are many type of reliability. Release 16, they have talked about for URLNC 10 to the power minus 6. Upcoming releases may have 10 to the power minus 7, or even in 6G region, they are talking about 10 to the power minus 7. So if you look at the standard, it was 10 to the power minus 6. So 5 QI value you should look at in 3GPP standard. There is a chapter on quality of service. There, if you go into 5 QI values similar to QCI of 4G, you will find that it is 10 to the power minus 6. Okay.
Okay, sir. Thank you.
Thank you. Okay, so let us look at what was India 5G IE technology, which I talked about. So let us look at that. So the India, as I had discussed, that we have a standard developing organization by the name of TSDSI in India. So the 5G I was developed under that particular organization. So all our IITs and all were involved. So what we did is like India requirement is of the rural area that I need a coverage. I need a coverage and I'm ready to compromise in mobility. Mobility means the requirement of 500 kilometers per hour. If I can compromise this, can I get more coverage? So that is called LMLC, low mobility, large coverage. Low mobility, large coverage. So for this, India, what they did that they took 3GPP standard of 5G that was released 15. And on top of this, using the same standard, on top of this, certain things were, standards were made so that coverage increases. Although we compromise on mobility, but we have more coverage to suit our rural environment. Initially, what we tried to go to 3GPP and try to put this standard into 3GPP, but somehow we were not successful. So we went to ITU and submitted this as one of the candidate technology, right? So finally, with a lot of lobbying and a lot of discussion, ITU they accepted India 5Gi technology as one of the 5G technologies. So they accepted 3GPP technology and also India 5Gi technology. So IT approved two technology for India 5Gi and 3GPP new radio. So that was 5Gi technology by how that came. But we still, continued effort with 3GPP to include as a single world standard instead of having two different standards, which will create a lot of problem in the ecosystem. And ultimately, it got merged into 3GPP 17. So what was there in 5Gi? So 5Gi, to increase the coverage, they had introduced pi by 2 BPSK modulation in for the uplink direction. So this was giving better coverage compared to the normal 5G technology. So 3 dB uplink coverage, no, 3 dB, you can understand that it doubles every 3 dB power is double. So that kind of advantage. And there were certain other features which were developed, which is called intelligent PWP configuration, low latency sounding reference signal for uplink direction, and intelligence PTRS and all. So some more technologies were added by India on top of 3GPP 5G technology. So this was in nutshell 5Gi technology. Okay, so now let us look at 6G. Morning also, I think I covered these two slides. Let us repeat that. Okay, so this is coming from Samsung. So 6G vision is not yet released by ITU. Please remember that ITU has not given its vision or the performance requirement for 6G. These are all being, every company is coming out with their own vision. Even India has released its vision document. So we are talking about a peak data rate of 1 terabyte per second, a user experience data rate of 1 Gbps, energy efficiency they are trying to double, spectral efficiency double, latency 0.1, connection density 10 to the power minus 7. So for Alok Tyagi, just see that reliability here they are talking about 10 to the power minus 7 in 6G. This is the Samsung vision. This is talking about 6G reliability to be 10 to the power minus 7. Right. And if you look at use cases which they have started talking for 6G, they have started talking about space tourism, tactile internet, fully automated car, holographic vertical, deep sea communication, digital sensing, and Internet of Bio. This B is for bio. Just like IoT, it's a biological kind of Internet of Things, which they have started talking about. So these all are various vision being conceived by different companies, different organizations. ITU has not yet come out with this. They'll take almost 6 more months or perhaps 7, 8 more months to actually release that document. So once ITU releases, that becomes de facto and every standard making organizations will start working on that. So with this, this particular slide is over.